Okay, so now what we have in store is a passage. The passage says point A, which is minus 2, comma 2, comma 3, and point B, which is 13, comma minus 3, comma 13. So now L is a line through point A. अब इससे कोरिलेटेड दो क्वेश्चंस हैं हमारे पास, जो कि है क्वेश्चन नंबर 12. अ पॉइंट बी P moves in space such that 3PA is equal to 2PB. Then find the locus of P. I think इसको सॉल्व करना काफ़ी इंटरेस्टिंग काम होगा. क्वेश्चन नंबर 13 पे आते हैं. वो होता है इक्वेशन ऑफ लाइन L परपेंडिकुलर टू द लाइन AB इज व्हाट. इसका पार्ट 2 है कि फाइंड कोऑर्डिनेट्स ऑफ द पॉइंट P which divides the join of A and B in the ratio 2:3 internally. So how do we solve all these?
So now let's get started with the solution. Here we would see that so in the question we are given 2 points A and B. A is given as minus 2, 2, 3 and B is given as 13, minus 3, 13. Let's join these points, and it's also given that line L passes through point A. This is line L. So a point P moves in space such that 3PA equal to 2PB. So this is the condition for locus given, which is 3PA equal to 2PB. Now let P be a general point with x and y coordinates as x, y, and z as well, because we are solving in 3D. We must not forget this, because it is a problem of 3D geometry, so it has to be a third coordinate present there. So 3PA equal to 2PB will square this, which so it would yield us 9PA square equal to 4PB square. Now by distance formula, if P is xyz and A is minus 2, 2, 3, then PA square would then become x plus 2 whole square plus y minus 2 whole square plus z minus 3 whole square whole raised to power 1 by 2. That is PA, and PA square would be just square of that. So this would yield us 9 x plus 2 whole square plus y minus 2 whole square plus z minus 3 whole square equal to 4 into x minus 13 whole square plus y plus 3 whole square plus z minus 13 whole square. Okay, this would yield 9x square. Actually we'll take the right hand term to the left, so the final condition would be yielded as 5 into x square plus y square plus z square plus 140x minus 60y minus 50z minus 1225, which is equal to 0. It's actually 1235.
Okay, इसमें जो हमने यहाँ पे सिंप्लीफाई किया है, इसमें हम लेफ्ट माइनस राइट कर रहे हैं. इसमें हम ए स्क्वायर माइनस बी स्क्वायर की प्रॉपर्टी नहीं लगा सकते?
नहीं, we cannot apply that a square minus b square property, because the coefficients of a square and b square are different, as well as a and b, like here x plus 2 whole square and it is x minus 13 whole square, so we cannot directly apply that.
So अगर हम 9 इंटू एक्स प्लस 2 के होल स्क्वायर को ए स्क्वायर मान लें, यानी 3x, अगर हम 9 को तो न्यूमरेटर के अंदर, न्यूमरेटर कह रहा हूँ, हम ब्रैकेट्स के अंदर ले जाएं, हाँ, और उसको हम 3x प्लस 6 का होल स्क्वायर कर दें, और हम राइट हैंड साइड को 2x माइनस 26 का होल स्क्वायर कर दें.
हाँ, ओके, वो किया जा सकता है.
तो इससे आई थिंक हमारी प्रॉब्लम थोड़ी शॉर्ट हो जाएगी.
हाँ हाँ, ओके, दिस वाज अ गुड पॉइंट. वी कैन डू दैट. सो लेट्स ट्राई बाय दैट मेथड इटसेल्फ. This would be 3x plus 2 plus 2x minus 13 into 3x plus 2 minus 2x minus 13 plus on so on.
So हम कॉरस्पॉन्डिंगली हम बस ये मेथड यूज़ करके हम ऊपर वाली इक्वेशन तक पहुंच सकते हैं.
हाँ, मतलब हम a स्क्वायर माइनस b स्क्वायर इक्वल टू a प्लस b इंटू a माइनस b, ये आइडेंटिटी का यूज़ कर रहे हैं इधर.
बिल्कुल सही. ओके, करेक्ट.
ओके, सो ये हमारी इक्वेशन हमें, like finally what it will yield is x square plus y square plus z square plus 28x minus 12y plus 10z minus 247 equal to 0. This is the required equation of locus of point P.
ओके तो ये इक्वेशन क्या एक स्फीयर की इक्वेशन है?
नहीं, हाँ, exactly it is. It is the equation of a sphere. We know the general equation of sphere is given by x square plus y square plus z square plus 2gx plus 2fy plus 2hz plus c equal to 0. This is the general equation of a sphere.
सो हमारा जो सोल्यूशन आ रहा है वो एक स्फीयर आ रहा है.
हाँ, वो exactly एक sphere आ रहा है. That's it.
सो मूविंग ऑन.
So now
Okay, now we come to another very good question. Question number 14 states that we are asked to consider a solid cube which is given to us. We need to find the angle between its body diagonals. So let us see how we'll tackle this question.
so let's get to the solution of this. The edge of the cube, the concept involved, the first concept would be the edge of the cube does not affect the angle which is made between the body angles. Say if edge of the cube is 1, then
Okay.
the shape of the cube is same. If edge is 2, again the shape is same, so angle would not change.
Okay, so it is independent of the edge.
Yes, so edge can be selected any, like it's not necessary that we take a random edge and then solve.
Okay, so we can assign any arbitrary value or we can assume it as a variable.
We can take anything.
Okay.
So better would be choosing it a arbitrary value, choosing it an arbitrary value.
Okay.
So consider a solid cube and then find the angle between its body diagonals. So first let us understand what are body diagonals. If this is a cube, so body diagonals are two vertices which are exactly opposite of each other.
Okay.
So like the side line joining two such vertices. So this is a body diagonal and this would also be a body diagonal.
Okay.
So there are total possibilities of 4 body diagonals because there are 8 vertices and each vertex has its pair for making a body diagonal.
Okay, would the angle between any two body diagonals be the same out of the 4?
Yes, it's because of the symmetry of cube.
Okay.
If it was a cuboid, then the angles would have been different, but as it is a cube, there's exact symmetry about the center. This center, that is point of intersection of these two body diagonals.
Okay.
So due to exact symmetry, the angle between any two diagonals would definitely be the same.
Fine.
So let's just get started. Better would be an easier approach would be placing the cube with one of the vertex as origin of the 3D coordinate system. This is x, this is x, this is y, and this is z. So let's place a cube here. This is a cube, okay?
Right.
So let's say the edge length is a which is an arbitrary value. So we'll consider two body diagonals, one of which has one vertex as origin. So this is 0, 0, 0.
Okay.
And this end is a, a.
Okay.
Because it is one unit each from all the 3 axes.
Correct.
And another we'll be considering this point and this point. Let's say this is O, A, and this is B, C. So B would be it has moved 1 unit along x-axis and 1 unit along z-axis and 0 units along y-axis.
Okay.
So the coordinates would be A, comma 0, comma a. It's
Okay.
actually a units along x, a units
since,
along z.
It would lie only in the xz plane and y component would
Yes,
be 0.
the y component would be 0. Similarly, for point C, we would have the x component would be 0 because it lies in the yz plane. Actually, it lies on the x axis, so x and z both would be 0.
Okay, it lies on the y axis.
Huh.
Okay.
So x and z both would definitely be 0. So 0, comma a, comma 0.
Fine.
Now we need to find angle between this line and this line. Let's say this, which is theta.
Okay.
Okay. So now we'll work it out using coordinate using 3D geometry. For BC, we'll first find the direction ratios of BC. Now we know for any line AB with its ends x1, y1, z1 and x2, y2, z2, the direction ratios are x2 minus x1, y2 minus y1 and z2 minus z1. So
Okay.
for the line BC, we would have direction ratios as a minus 0, comma 0 minus a, comma a minus 0, which are like coordinates of a minus coordinates of b. And for OA, we will have it as a minus 0, comma a minus 0, comma a minus 0, which are coordinates of a minus coordinates of origin, which is simply a comma minus a comma a, which is simply a comma a comma a.
Right.
Now we would apply the formula for cosine of the angle between two lines with given direction ratios.
Okay.
That is, which we learned, cos theta is summation a1 a2 by root of summation a1 square into root of summation a2 square. This is very important formula.
What is A1 and A2 in this formula?
A1, B1, C1 are the direction ratios of first line.
Okay.
And A2, B2,
are the
C2
direction ratios of the second line?
Yes.
Sure.
So this would correspond to A1, B1, C1, and this would correspond to A2, B2, C2.
Okay.
Okay, so this would give us this is a square minus a square plus a square, which would give a square minus a square plus a square upon this would be root of a square plus minus of a square plus a square, which is 3a square,
Yeah.
and again 3a square, which is 3a square.
Okay.
That the root 3a square, that whole square, which comes out to be 1 by 3. Therefore theta is the angle between the two body diagonals, which comes out to be cos inverse 1 by 3.
Okay. So in this question, the important concept covered is that of direction ratios, which are used for determining the angle between the body diagonals of a cube. We also use the formula, the cosine formula, which is used for determining the angle between any two lines when their direction ratios are only given to us. So as you can see, it is a simple problem if you know the concepts behind it, and we have easily found out the solution.
Yes.
Alright, now we are starting with question number 15, which says that plane 1 has the equation x minus y minus z minus 4 is equal to 0. Plane 2 has the equation x plus y plus 2z minus 4 is equal to 0. Plane 3 has the equation 2x plus 3y plus z minus 1 is equal to 0. Plane 4 has the equation x plus 3y plus 2z minus 2 is equal to 0. And plane 5 has the equation x plus ay plus bz plus c is equal to 0. Oh my god, so many planes. Right, now we move to the what is given in the question. Plane 5 is parallel to the lines of intersection of P1, P2 and P3, P4. P5 passes to the point 4, 0, 0. Find the value of mod a plus b plus c by 11. Oh wow, very tedious question.
So the question may look difficult initially, but as we move on, as we apply the basic concepts properly, the question becomes easy. So now we move on to the solution of the question. Here, plane 1 and plane 2 would intersect in a line. We know that two planes intersect in a line always. So let's see that how it occurs. This is plane these two planes intersect in this line.
All right, right.
Okay, so now there would be one line of intersection of plane 1 and plane 2 and one line of intersection of plane 3 and plane 4, which is given. And now these two lines are perpendicular to plane 5, which is given in the question. Also-
It's parallel to right?
Sorry, it's parallel to the plane 5.
Right.
And it's also given that plane 5 passes through the point 4, 0, 0.
All right.
So, first applying this condition that plane 5 passes through the point 4, 0, 0, we'd get first equation, which is 4, that is 4, 0, 0 lies on P5, which implies 4 plus 0 plus 0 plus C equal to 0. This would give us the value of C, which comes out to be minus 4. Okay. Now we'd apply, we'd find out the equation of the two lines, that is the line of intersection of P1, P2 and that of P3, P4. So how to find this? We know that if there is a plane and there's another plane, both intersect in a line. So this line, that is the line of intersection of the two planes, is perpendicular to normals of both the planes.
Oh, right.
This is a very important concept which needs to be applied in this question.
तो हमें याद रखना चाहिए.
हाँ, this is N1 and this is N2. So N1, N2 both are perpendicular to the line L1, and similarly N3, N4 are perpendicular to line L2. This is the most important concept involved in the question. If this concept clicks to us, then the whole question is solved. So now let us assume that direction ratios of the line L1 is line of intersection of plane P1 and P2, and L2 is line of intersection of planes P3 and P4. So if A1, B1, C1 are direction ratios of L1 and A2, B2, C2 are direction ratios of L2, then line 1 is parallel to N1 and also to is perpendicular to N1 and also to N2. Now N1 has the direction ratios 1, minus 1, minus 1, and N2 has direction ratios 1, 1, 2, which is obtained directly by comparing the general equation of the plane.
बिल्कुल सही.
So we would obtain equations. We know that cos theta equal to summation a1 a2 by root of summation a1 square root of summation a2 square. This is also the formula we need to remember. Here it is known that they are perpendicular, so theta equal to 90 degree. So this would give us summation a1 a2 is 0. Here a1, b1, c1 are direction ratios of L1, and in this specific case this a2 corresponds to direction ratios of this plane. Okay, so we will now be obtaining two equations for a1, b1, c1, which would be given as a1 upon minus 1 equal to minus b1 upon 3 equal to c1 by 2, which we have obtained from a1 minus b1 minus c1 equal to 0 and a1 plus b1 plus 2c1 equal to 0. Similarly, for a2, b2 and c2, we will obtain 2a2 plus 3b2 plus c2 equal to 0 and a2 plus 3b2 plus 2c2 equal to 0. This would give a2 by 3 which is minus b2 by 3, which is c2 by 3. So as direction ratios are proportional numbers, so we would get, so as direction ratios are proportional numbers to direction cosines, so we can take a1 equal to minus 1, comma b1 equal to minus 3, comma c1 equal to 2 as one of the possible values of a1, b1, c1, and a2 equal to 1, b2 equal to minus 1, and c2 equal to 1. This is a set of possible values for lines L1 and L2 respectively. Okay, so now we know that the final plane is going to be parallel to these two lines. That is, this is our final plane, this is line L1 and this is line L2. So the plane is parallel to both these lines. So the normal to the plane would be perpendicular to both these lines. So now the plane's equation, that is this plane is P5. Plane's equation is given to be x plus ay plus bz plus c equal to 0. So normal to this plane has direction ratios 1, a, b. Okay, so now as L1 has direction ratios minus 1, minus 3, 2, and L2 has 1, minus 1, 1, we would have as summation L1, L2 equal to 0 for perpendicular, that is, this is the condition of perpendicularity. So we would get 1 into minus 1 plus minus 3 into a plus 2 into b equals 0. That is 3a equal to 2b minus 1, and we would get another equation as 1 into 1 plus a into minus 1 plus b into 1 equal to 0. This would imply b plus 1 equal to a. So these two equations would give values of a and b, which are found to be a equal to minus 3 and b is minus 4. Earlier we had obtained the value of c as minus 4. So a plus b plus c will come out to be minus 11. So mod of a plus b plus c would be 11, and mod of a plus b plus c upon 11 would then come out to be 1. This is our final answer.
सो काफ़ी लंबा क्वेश्चन था, हम समराइज़ कर लेते हैं हमने क्या किया. तो पहले हमने कैसे शुरुआत की, हमने पहले हमें क्या दिया हुआ था, हमें पहले दिया हुआ था कि एक 5 प्लेन दिए थे हमने बिगिनिंग कैसे की. हमने बिगिनिंग में देखा कि 2 प्लेन्स इंटरसेक्ट एक लाइन में करते हैं. तो हम उस लाइन के हमने बेसिकली डायरेक्शन कोसाइंस निकाले.
एग्जैक्टली,
डायरेक्शन कोसाइंस या डायरेक्शन रेशियोज निकाले.
हाँ,
ठीक है. फिर हमने उनके डायरेक्शन रेशियोज कैसे निकाले, क्योंकि हमें पता है जो 2 प्लेन्स इंटरसेक्ट करते हैं, जो लाइन ऑफ इंटरसेक्शन होती है वो परपेंडिकुलर होती है,
वो दोनों से परपेंडिकुलर होती है.
ये इंपॉर्टेंट रिजल्ट है ना.
यस.
ओके, फिर हमने उनके डायरेक्शन रेशियोज निकालने के बाद फिर हमने जो प्लेन से वो परपेंडिकुलर से डॉट लिया, और उसके बाद फिर हमें 2 इक्वेशंस मिली जिससे हमें ए और बी निकल गया.
2 इक्वेशन से हमें लाइन का डायरेक्शन कोसाइंस मिल गया.
डायरेक्शन कोसाइंस मिल गए, और सी हम पहले ही से निकाल
नो, एग्जैक्टली डायरेक्शन रेशियोज मिले हमें.
ओके, हम करेक्शन यहाँ पे हमें डायरेक्शन रेशियोज मिले, और फिर हमने मॉड a प्लस बी प्लस सी की वैल्यू निकाल के इवैल्यूएट कर लिया.
ओके,
सो दैट फिनिशेस द क्वेश्चन.